Hello dear students, welcome to physics online classes for class 12 students. Today I am going to start a new chapter number 6, that is electromagnetic induction. As we have completed the first 5 chapters and they are electric charge and field, electric potential and capacitance, current electricity, moving charges and magnetism, magnetism and matter. The first 5 chapters we already completed. Now we can start chapter 6, electromagnetic induction. If you understand the first 5 chapters, then it is easy to understand chapter 6, that is electromagnetic induction. This chapter is very easy and interesting chapter. So today we can learn the introduction part regarding electromagnetic induction. Yes, before going to start the introduction part about this chapter, first we have to know what are the topics to be covered. So totally 10 points or 10 topics we are going to study in this chapter. The first point is introduction. Second point, the experiments of Faraday and Henry that you have already studied in your high school days in 10th standard that you can remember. Then third point, magnetic flux. You have studied about electric flux, electric field and magnetic field. Now in this chapter you are going to study about magnetic flux. Fourth point, Faraday's law of induction. Totally there are 2 laws of Faraday which is very important. And fifth point, Lenz's law and conservation of energy. Sixth point, motional electromotive force. Seventh point, energy consideration. Eighth point, eddy currents. Ninth point, inductance. In inductance, you are going to study about self-inductance as well as mutual inductance. And the last point is AC generators. So these are the topics you are going to learn in this chapter. Now today we can start with introduction. Yes, now let us start the chapter electromagnetic induction. So today we are going to study about introduction of electromagnetic induction. Yes, first we have to know what is electromagnetic induction. As we have studied in the previous chapter about electric charge, electric field, electric potential and what is electric current, how the magnetic field produces. So these terms we have studied in the previous chapter. We know that when a charge is at rest, static charge is always surrounded by electric field. Right? Then when that charge is moving in a specific direction, then that moving charge produces electric current. Then that electric current is surrounded by or moving charge is surrounded by both electric field and magnetic field. That indicates changing electric field produces magnetic field. About this phenomenon we have studied in the previous chapter. Yes, what we have studied? When charge is at rest, it is surrounded by electric field. When the charge is moving, then it is surrounded by both electric field and magnetic field. That indicates changing electric field produces magnetic field, or this electric current generates magnetic field. So here electric current or the moving charge is surrounded by both electric field and magnetic field. But here in this chapter we are going to study the reverse process. When changing electric field produces magnetic field, then why not the changing magnetic field produces electric field or electric current? The reverse process, if it is possible or not. About this phenomenon, we are going to study in this chapter, and it is electromagnetic induction. Induction, induced, means we are going to generate or we are going to produce electric current by changing magnetic field. So about this phenomenon we can study in detail in this chapter. Yes, see here the scientist Oersted, Ampere and few other scientists, they established the fact that electricity and magnetism are interrelated. There is an interrelation between electricity and magnetism. So what is that relation? Yes, we know that electricity means electric current. Electric current and magnetism, magnetic field, they are interrelated because electric current produces magnetic field. Likewise, in the reverse order, this magnetic field also produces electric current. So there is a interrelation between electricity and magnetism, and it was established by the scientists Oersted, Ampere and few others. Then Oersted, Ampere and other scientists, they found moving charges produce magnetic field. Yes, we already studied about this concept. We know that moving charge produce magnetic field. When a charge is at rest, then it is surrounded by electric field. When the charge starts to move, then it will produce magnetic field. So these scientists, they found moving charges produces magnetic field. For example, an electric current deflects a magnetic compass needle. Electric current that deflects a magnetic compass needle when it is placed in its vicinity, means in its surrounding place. When we are going to keep a magnetic compass needle in front of that electric current, then it will deflect that compass needle. Yes, what is the example here? An electric current deflects a magnetic compass needle when it is placed in its surrounded area or in its vicinity. Here, magnetic compass needle is deflected. It is because of electric current. That indicates electric current is producing magnetic field. Because of that magnetic field, compass needle is deflected. Now the question arises, can moving magnets produce electric current? See here, in the previous chapter we studied electric current produces magnetic field. Is it clear? Electric current produces magnetic field. Now in the reverse order, we have the question, can the moving magnets produces electric current? Moving magnets means we know that magnet is surrounded by magnetic field. When we start to move the magnet, the surrounded magnetic field lines also changes. Right? When the magnet is moving, that indicates magnet is surrounded by magnetic field. When the magnet is moving, so that the surrounded magnetic field also changes. When that magnetic field changes, whether it produces electric current? Think of this question. We studied electric current produces magnetic field. Now the question is, can these moving magnets produce electric currents? Yes. We can produce electric current just by moving the magnet. Moving magnets produces electric current. It is exactly the opposite or the reverse process. Is it clear? So remember, this is the important concept you have to understand before going to study the detail of electromagnetic induction. Yes, see here, electric current produces magnetic field. Similarly, that magnetic field also producing electric current. The moving magnets produces electric current. Yes, it is right. We are going to produce electric current by moving magnet. So it was found by the scientists Faraday and Henry. The experiments of Michael Faraday and Henry, they concluded that electric currents were induced in closed coils when subjected to change in a magnetic field. What they concluded? Michael Faraday and Henry, they did some experiments and they concluded that electric currents were induced in the closed coils when it is subjected to changing magnetic field. That means when that closed coil is kept very close to the changing magnetic field, then we can easily produce electric current. It was concluded by the scientists Michael Faraday and Henry. They did some experiments. Later you are going to study all the experiments done by the two scientists Michael Faraday and Henry. What they concluded? They concluded that electric current were induced in the closed circuit or in the closed coil when it is subjected to change in magnetic field. Is it clear? Remember, only by using moving magnets, only by changing magnetic fields, we can produce electric currents. Right? So, in this chapter, we will study the phenomenon associated with changing magnetic fields. In this chapter, we are going to study the phenomenon, the principles which are associated with changing magnetic fields and understand the underlying principles. We are going to study some phenomenon associated with changing magnetic field. So this sentence is very important. This changing magnetic field that produces electric current. Yes, observe these points. Moving electric charges creates a magnetic field. Yes, we have studied. When electric charge is moving, it will create or it will produce magnetic field. Then second point, a changing magnetic field that creates an electric field. This effect is called magnetic induction. Yes, we know that moving electric charge creates magnetic field. Likewise, a changing magnetic field creates electric field. And this effect we are going to call it as magnetic induction. And this links electricity and magnetism in a fundamental way. So this sentence that gives the connection between or it gives the interrelation between electricity and magnetism in a fundamental way. So this is very important concept. Remember, static charge surrounded by electric field, moving charge surrounded by electric field as well as magnetic field, that indicates changing electric field produces magnetic field or electric current produces magnetic field. In the reverse order, we can check it now. Changing electric field when it produces magnetic field, then why not changing magnetic field produce electric field? Yes, the scientists Faraday and Henry did some experiment. They found yes, it is possible. Changing magnetic field also produces electric current or changing magnetic field creates electric field and that gives relation between electricity and magnetism. Then next point you can observe magnetic induction is also the key to many practical applications. Just by using this concept, magnetic induction, just by changing magnetic field, we are producing electric current. It is having many practical applications. For example, speedometer, electric trains, induction stove. So these are some practical applications and these devices works basically on the concept of magnetic induction. So then what is electromagnets? See here, electromagnets, the magnetic field due to electric current, and it was invented by the scientist Oersted in the year 1820. What is electromagnet? The magnetic field which is produced due to electric current. So we are going to call it as electromagnet and it was invented by the scientist Oersted in the year 1820. Then the scientist Oersted discovered that what he discovered? An electric current in a wire that can exert a force on a compass needle. When we kept that magnetic compass needle in front of the wire which is carrying electric current, so that will exert a force on the compass needle and the needle starts to deflate. Then third point, what it indicates? It is indicated that an electric field that can lead to the force on a magnet. That means when a wire is carrying a current, it is surrounded by electric field and magnetic field. In front of the wire, I am going to keep a magnetic needle. When that wire is carrying a current, then it is exerting force on the needle. This electric field exerts a force on the compass needle and this compass needle starts to deflect. That indicates an electric field can lead to a force on a magnet. Who is applying force on this magnetic needle? Electric field. And this electric field is surrounded by moving charge. Right? You can observe this diagram. So this is a wire which is carrying electric current. It is surrounded by electric field and magnetic field. So when we kept this compass needle in front of this wire which is carrying electric current, so it starts to deflect because this electric field exerts force on the magnet. So this compass needle starts to deflate. Then he concluded that an electric field can produce magnetic field. Is it clear? Electric field can produce magnetic field. Then we can observe some multiple choice questions on this concept. The first question, a changing magnetic field creates. What it creates? A changing magnetic field creates. Options. First one, electromagnetic field. Option B, electric field. Option C, both A and B. Option D, none of these. A changing magnetic field creates. What it creates? Electric field. Remember, changing electric field creates magnetic field. Likewise, a changing magnetic field creates electric field. Then, second one, the phenomenon in which electric current is generated by varying magnetic fields is called. Observe the statement here or the definition. The phenomenon in which electric current is generated. We are going to generate electric current. How? Only by varying, by changing magnetic field. By changing magnetic field, we are going to generate electric current and it is called options. The first one, self-induction. Option B, mutual induction. Option C, electromagnetic induction. Option D, none of these. Yes. Which is the right answer? Observe the definition. The phenomenon in which electric current is produced by changing magnetic field is called electromagnetic induction. Is it clear? What is electromagnetic induction? It is the phenomenon in which the current or the electric current is generated by varying magnetic field. So this is just the brief introduction to the chapter electromagnetic induction. Yes, what is electromagnetic induction? The phenomenon in which electric current is generated by changing magnetic field. It is just the reverse process of the previous chapters. Yes, quickly revise once again what we have studied in the previous chapters, because if you understand the previous chapters, then it is easy to understand about electromagnetic induction. Yes, we know that static charge is surrounded by electric field. Moving charge produces electric current, which is surrounded by electric field, changing electric field. and that changing electric field produces magnetic field. Anyhow, electric current is surrounded by electric field as well as magnetic field. This concept we have studied. That indicates electric current is producing magnetic field. We can call it as electromagnet. The reverse process we can observe in this chapter. What is that? When electric current produces magnetic field, likewise, this changing magnetic field also produces electric current. Just by changing magnetic field, we are going to produce electric current, and this is called electromagnetic induction. So this is all about a brief introduction to the chapter electromagnetic induction. So the next part we can continue in the next session.